So today we will determine when it is appropriate for us to use the chain rule for trig derivatives. So here's the too long, didn't read. The purpose of the chain rule in calculus is to enable us to find the derivative of a composite function. What is a composite function? Let me just zoom in a little here. Let's say we had a function f of x, which returns the value of x squared. And if I gave you the value f2, this would be 2 squared, which is equal to 4. Simple. But what if instead I gave you f g of x, and now you have to return g of x, whatever that may be, squared, and g of x is equal to x cubed. Well, then this would now become x cubed all squared. So a composite function is a function within another function. The chain rule provides a method for calculating the derivative of this function. It's necessary because the rate of change of a composite function depends on both the change of the outer function and the rate of change of the inner function. By applying the chain rule, we break down the process of finding the derivative of a composite function into smaller steps. So let me go ahead and erase everything. I'll actually leave it, it's fine. So let's actually examine the chain rule here before we go forward. Notice. If y is equal to f composite g, then the derivative of y is equal to the derivative of f multiplied by g multiplied by the derivative of g. That one is a little weird. Look at this one. This states that the derivative of a function f that takes as parameter another function g is equal to the derivative of the first function, in this case f, just multiplied by the second function g, all of that multiplied by the derivative of g. Let's go ahead and show you. So this is an important table. It is a table of your trig functions and their associated derivatives. This is a table that you need to know. If you don't know it, you need to know how to derive it from first principles. For our examples here, just for sake of simplicity, I will only be using sine of x, but it doesn't matter which function you are given. So we have three situations. First situation, first being a trig function of the form f constant, where f is any trig function. So for our example, let's say I have sine and I have some constant, I'll just call it c. We know that the derivative of any function that takes as a we know that the derivative of a trig function that takes as a constant will always be 0. Why? Because the trig function itself, when it takes as parameter a constant value, it will return a constant value. And the derivative of a constant value is equal to 0. So down there is quite simple. Here's the second situation. Say we have any trig function, example, sine of x. So it's the form of any trig function right here. So trig function and stand alone variable, or at least I call it standalone variable. And this can be anything. So it can be sine x, it can be sine y, it can be sine a, it can be let's be a little different, it can be cosine b. This is the form of any trig function which takes as parameter a single standalone variable. In that case, the derivative will simply be the associated value in this table right here. So if we had the derivative of sine of x, this would just be cosine x. If it's a, it'll be cosine a. If it's b, it'll be cosine b. Similarly, the derivative of, say, cosine y, because you notice we have a single standalone variable right there, and we notice we have a single trig function right here, and a single standalone variable. We just use the associated derivative. It will be negative sine y. Simple. In our third situation, I need a new color. Damn it. Let's see. Just gonna go here. Let's go with that. Looks cool. So third, this is the situation called where the chain rule is used. This one is very simple. If you are given any function and it is not of the first situation or the second situation, we use a chain rule. So the chain rule is used when a trig function is not of the form from situation 1 or 2. Here's an example. Let's say we're given sine of 2x. Our first situation said you would be given a trig function which takes as parameter a constant. Well, we see our parameter is 2x. Is it a constant? No. Therefore, it's on situation 1. In situation 2, we did say a single trig function, which we are given. Sine right here is a single trig function. But 2x is not a standalone variable. It is 2x. A standalone variable would be a variable by itself. Therefore, the derivative of this side, 2x, would be the derivative of some function f, which takes as parameter some function g, which would return would be the derivative of f multiplied by g multiplied by derivative of g, which would be derivative sine 2x will be equal to, what's the derivative of sine? It's cosine. Well, what about 2x? That stays the same. Multiply by derivative of 2x. Derivative of 2x is just 2, which would result in 2 cosine 2x. And that's it. Let's go ahead and do an example. Do I have my examples here? No, I don't. So let me go ahead and see if I can find it. Here we go. So I'm just going to pull these values. So let's determine the derivative. So if we're given f of x is equal to x to the 5th power multiplied by cosine x. The derivative of this, we know this is a product, therefore we'll use a product rule. It's going to be 5x4 simply multiplied by cosine x plus x to the 5th power multiplied by negative sine x, which would be equal to 5x4 cosine x minus x5 sine x. Now notice here, we did not use the chain rule. We had the product rule associated with a simple trig rule. Why is this? Why is this the case? Because this is this right here, cosine x, is situation 2. Well, what is situation 2? Situation 2 states any trig function, e.g. sine, or cosine, he has cosine, and a standalone variable, which is what we had. We had cosine x with a standalone x variable. Therefore, we just take the associated derivative. Well, what about this one? We have f of x equal to sine 2x, x plus 1. Notice, we have a trig function, but there is no constant. Therefore, situation 1 is ruled out. Second, we have a trig function, but we don't have a standalone variable. Therefore, situation 2 is ruled out. This only leaves us with situation 3, which states we must use the chain rule. The chain rule is quite simple. We say the derivative of f of x is equal to the derivative of f of x multiplied by derivative, multiplied by g of x. What am I doing here? It's the derivative of f multiplied by g, or multiplied by the derivative of g, which would equal to the derivative of sine is cosine. Whatever is in our parameter will stay the same. 2x, x plus 1, multiplied by derivative of g, where g is equal to 2x divided by x plus 1. This is where we use the quotient rule, which states that we take the derivative of the top, so the derivative of 2x would be 2 multiplied by the bottom, x plus 1, minus the top, multiplied by the derivative of the bottom, which is just 1, all over the bottom squared. And this is our function. And we can leave it this way. You don't need to go and expand. This is fine. That's perfect. Let's go ahead and save everything. Let's go here and let's check our answer. 5x4 cosine x minus x5 sine x. 5x4 cosine x minus x5 sine x. Sine x, yeah, that's right. And the bottom we have cosine 2x x plus 1 all multiplied by 2 right here. 2x plus 1 minus 2x into 1 divided by x plus 1 all squared, which is what we have here. And that's that. Quite simple.